Okay, we're here at go-to-math.com. Click on the algebra. Let's go down. We got a new section we're working on here, complex fractions. Of course, that needs to be filled out. Simplify the complex fraction. Okay, so we're not going to actually write these like you're seeing here, but I thought I would throw this in. Over x. So you'll kind of know this notation. Okay, so we want to simplify the complex fraction. Let's move over to the whiteboard. Alright, so we've got 5 over x, and that is all over x over 20. X over 20. Okay. Now if you had to type this into a calculator, this is like a linearized form here. You would want to type it in like this, or if you were typing it in on some website that does the calculations like Wolfram Alpha. But so as you can see here, however, we're going to simplify this down so you don't have to write it like that. Okay, so the way this reads is we've got 5 over x divided by, so you should know this from the previous section, of x over 20. Okay, but written in this form is known as a complex fraction. And what we'll want to do next is we're going to convert that division sign to multiplication, and then we end up flipping this part here like such. Okay, and then what do we got? 100 over x squared. 100 over x squared. Let's click on the answer there. We get 100 over x squared. Of course, I don't know if I checked any of those in the previous section in the checkbox here, but we'll do that just to make sure everything's good. Okay. Alright, so there you go. We're over here at go-to-math.com working on complex fractions. See you in the next problem. Okay, we're over here at go-to-math.com. Click on the algebra. Let's go down to complex fractions. 1.2 is what we're looking at. Okay, so this is the better form, I guess. We've got 13 over x to the 24th, and that's all over 1 over x to the 13th, and we want to simplify this complex fraction. Okay, so we got 13 over x squared, and that's all over 1 over x to the 13th. So remember, this is like writing 13 over x squared divided by 1 over x to the 13th. But remember, we're going to do the conversion here. Right, we changed that to multiplication, but we got to flip this. And of course over 1, right? So we multiply 13 times x to the 13th, which is just going to be that guy right there over x squared. Now, that all that said, we need to keep simplifying. So we got 2 x's in the denominator. We have 13, so we want to subtract 2 x's up here. Now remember how we deal with this. Right, and then we add our exponents. And we end up with to the 11th. Is that right? X to the 11th. 13 minus 2 is 11. Okay. Yeah. Oh, wait a minute. Squared. Sure, I got the right problem. 13x to the 24th. Did I not? What the heck? I knew something was fishy here. over x to the 13th. Okay. Guess that makes more sense now. Alright. Make a few corrections here. We got 13 minus 24. There's a negative 11. Right. So we end up with 13 over. We want to write with positive exponents. 13 over x to the 11th. Let's get the stuff written down correctly there. 13 over x to the 11th. Okay. Alright, so over here, go to math.com. We're going to complex fractions C in the next problem. Okay, we're over here, go to math.com. Click on the algebras, go down to complex fractions. We're looking at 2.1. 2.1. Okay. Write that down. AX over 9y, and that's all over 13. Alright. So we have AX over 9y, and that's all over 13. So we want to rewrite this as AX over 9y. I guess we could write equals there. Divided by, okay, 13. Right, divided by 13. Then we want to convert. So we have AX over 9y times. When we flip that, right, this is really 13 over 1, so we end up with 1 over 13. And there's nothing we can actually factor out here and cancel. So we'll just have to multiply 9 times 13. Right, and that's going to be 90, 107. It's close anyway. 117. I was off by 10. Okay, so there you go. 8x over 117. Y. Don't forget the y. What happened to my y? I just forgot my y. There it is. What the heck? Okay. Time to wake up. We're over here, go to math.com, trying to wake up. Whoops, didn't mean to do that. Go back. Anyway, we'll see you in the next problem. Okay, we're over here, go to math.com. Click on the algebra. Let's go down to complex fractions, and we're looking at 2.2, I believe. 2.2. Okay. So we have 4 over 3x over 2y. We want to simplify that guy or girl or whatever it is. 4 over, and that's 3x over 2y. So we're going to rewrite this as 4 divided by 3x over 2y, but then we want to convert division to multiplication, so we're going to flip this. 2y over 3x, and there's nothing we can cancel out, so we end up with 8y over 3x. Okay, pretty straightforward there. 8y over 3x. Hopefully I didn't leave anything off. Okay. Yep. Alright, we're over here, go to math.com. See you in the next problem. Alright, let's go up to algebra, go down to complex fractions. We're looking at 3.1. We have 19 over x plus 2. And that's all over 19 over y plus 5. And we want to simplify this guy down. Alright, get it all into one single fraction. With just a one denominator and one numerator. How's that? So we have 19 over x plus 2, and that's all over 19 over y plus 5. So we're going to rewrite this as 19 over x plus 2. And, it'll get to the point where you just kind of skip steps there. But we're not going to skip any steps just yet. So rewriting the left side, convert that to multiplication, flip that. And as you can see here, we can, we don't want to erase anything, just change color. We can cancel those guys, cancel them out. All right. And so we're going to be left with y plus 5 over x plus 2. Kind of did a little slide there. All right. Y plus 5 over x plus 2. Let's hope that's what it is. Yep, that's what I'm getting there. Okay. Alright, so we're over here at gotomath.com. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to complex, and we're looking at 3.2. Ooh, things are starting to get a little hairy. X squared minus 361. Whoa. What is that? X plus 19 over x minus 19. There's a bunch of 19s going on in there. So we have 19 over x squared minus 361, and that's all over x plus 19 and x minus 19, it looks like. Alright, so we're going to rewrite this. We should be skipping steps at this point, but not yet. Alright, so what we'll want to do here is go ahead and we'll rewrite the left-hand side. And this is in question down here because I've got a feeling we're going to be able to factor that. But we'll get to that here in just a second. Change that to multiplication and flip this fraction. Like such. Okay. Now let's take a look at this. I got a feeling that might be 19 squared, but I'm not 100% sure. 19 times 19. Let me think about that for a second. 6. Yep, it is. Alright, a little side work over here. So we have x squared minus 19 squared. Oh, excuse me. So this is the difference of two squares, remember? Talked about that earlier in some other sections. That could be factored to such. Okay, so we have 19 over x minus 19 times x plus 19, and that's multiplied by x minus 19 over x plus 19. Alright, so we got an x minus 19 up here and one down there, so we can cancel those, cancel them out. And so now we're going to be left with, it looks like a 19 on top over, now you could write it this way. See that? Because there's two of them, x plus 19 times x plus 19. However, I'm probably going to end up multiplying that stuff out. You know, x squared, what was that, 361? 19 times 19, yeah. And then, let's see, that's going to be 20, that would be 40, I think that's 38. 38x, right? I more than likely have it written like this on the web page, but we shall see. Yep, I did. I multiplied it out. 19 over x squared plus 38x plus 361. Yeah, even though that's That's legal. You can write it like that too. Right. Okay, so we're over here, gotomath.com. Get it worked out. See you in the next problem. Okay, we're over here, gotomath.com. Click on Algebra. Let's go down to complex fractions. Looking at 4.1, it looks like. 4.1. So we got x minus 1 over 5x plus 40. And that's all over x plus 1 over x plus 8. Got it. Alright, you know, we can factor a 5 out of there. I see that. We'll get to that here in a minute. So we have x minus 1 over 5x plus 40, and that's all over a squiggly line, it looks like. X plus 1 over x plus 8. Okay, so we can rewrite this, and I'm going to skip a step here. Alright, so instead of writing divided by here, I'm just going to go ahead and skip that step, hit multiplication, and we want to flip this fraction, so we end up with x plus 8 on top and x plus 1 on bottom. So we're getting to the point where you should be able to follow that. Alright. Well, remember, I said something earlier, we can factor a 5 out. So we end up with x minus 1 over 5 times x plus 8 times x plus 8, and that's over x plus 1. So as you can see here, we've got x plus 8 in the numerator and 1 down here in the denominator. And of course that's a minus and that's a plus, so can't cancel them out. And what are we left with? Well, we're going to be left with x minus 1 over, and I'm going to go ahead and distribute that 5 across, so it's going to make that a 5x plus 5. Right, x minus 1 over 5x plus 5. There it is. Alright. So we're over here, gotomath.com. See you next problem. Okay, we're over here, gotomath.com. Click on the algebra. Let's go down to complex fractions. We're looking at 4.2, it looks like. Simplify the complex fraction. Alright, so we got x minus 12 over 10x plus 170, and that's all over x plus 12 over x plus 17. Okay. X minus 12 over 10x plus 170. Then we have x plus 12 over x plus 17. Alright, so we can rewrite this, and I am going to skip a step now, like I did in the last problem. Instead of writing divided, I'm going to write multiplication, and we're going to go ahead and flip those fractions. So we have x plus 17 over x plus 12. Now, it looks to me like we're going to be able to factor a 10 out of the bottom of that. So we're going to have x minus 12 over 10 times x plus 17 times x plus 17 over x plus 12. Okay, so as you can see, the x plus 17s are going to cancel out, and we're going to be left with x minus 12 over 10x plus, it looks like 120. X minus 12 over 10x plus 120. Let's see what we got going on here. Let's make sure everybody's good. X minus 12 over 10x plus 120. Okay. Okay, so we're over here, GoToMath.com. See you in the next problem. Okay, we're over here, GoToMath.com. Click on the algebra. Let's go down to complex fractions. And we're looking at 5.1. We'll just click on a button. How's that? 5.1. And let's see, we got x minus 8 over 7x to the fourth. Alright. Okay, we've got x plus 8, just checking my work, x to the 22nd, x minus 8, 7x to the fourth. Alright. X plus 8 over x to the 22nd, and that's all over x minus 8 over 7x to the fourth. So we're going to rewrite this. We're going to skip an intermediate step. At least I call it an intermediate step. So instead of writing division, we're going to go ahead and write multiplication, and we're going to flip this fraction here. So 7x to the fourth over x minus 8. I don't see anything canceling out here. Well, wait a minute. We've got, yeah, there is something going on. We've got 4 x's in the numerator and 22 down here, so that's going to be 22 minus 4 is 18. So that's going to be an 18 there. All right, so we're going to end up with 7x plus 8. All those guys canceled out, and we were left with an x to the 18th and x minus 8. Now, more than likely, I'm going to distribute this stuff across. We'll just write it over here. Let's see, 7 is 56. And distribute that across. We're going to have x to the 19th minus 8x to the 18th. So I got a feeling that's probably how it's going to be written out. We shall see. We shall see. I don't remember what it was. 7x plus 56 over x to the 19th minus 8x to the 18th. X to the 19th minus 8, yeah. Whoops, I about pushed the wrong button there. Alright. So we're over here at GoToMath.com. Working it out. See you in the next problem. Okay, we're here at GoToMath.com. Click on the algebra. Let's go down to complex fractions. And we are looking at 5.2. Looking at 5.2. So we got x plus 9 over 14y to the 14th, and that's all over x minus 3 and 16y cubed. Got it. Okay, what are we doing? I guess we're going to the whiteboard. Started thinking about other things there. It's the first nice day we've had of the year. And I need to get out there and do some planting. I'm thinking x minus 3. I'm just so glad winter is over. Envy all those people that live in nice regions where it's warm all year. Especially people who live around down around the south of Florida. Or I guess there's a lot of other places in the world. Let's see. What are we doing? We're going to flip this guy. I hadn't ever figured it out why people want to live in cold regions. It's like, move if you can, I guess. If you can't, sorry. What are we doing here? We're going to cancel some stuff out. This y cubed is gone, and there's 3 of them up here, right? So we're going to cancel 3 of them out down here. That's going to make that a y to the 11th. Okay? A y to the 11th. So we got x plus 9, and I should go ahead and put the 16 right here. And then, of course, you know, I have a lot of people from Africa that watch my that watch this stuff, and you know, all I know is what I see on TV. Of course, I can get on the internet, I guess. Look at Google Earth, which I don't think I've ever done that before. Been to Africa. We got what? Well, actually, I have been to Africa. Or have I? No, I don't think I have. Let's see. Y to the 11th. X minus 3. No, I don't believe I ever have. Alright, what do we got? That may just be a little too hot for me. Anyway, we can reduce 16 over 14. Let's see, what do we got? 2, 4, that's 2 and 7. I guess 2. 2 goes in 16 8 times, and I guess we won't skip any steps on that. And then that's all over. This, I gotta figure out how to get rid of this. This thing's annoying me. And then that's going to be 7y to the 11th. And 7y to the 11th. Sorry, I got distracted. X minus 3. More than likely, I'm going to end up distributing this thing across 8x plus 72. And that'll probably get distributed across. So let's find out what happens here on that. I mean, they're still both equivalent. What are we doing? 8x plus 72, 7y to the 11th x, or 7xy to the 11th, minus 21y to the 11th. Let's see what's going on here. So 7 times 3 is 21, then you'd have the y to the 11th. Okay. Alright, so hopefully you caught that. You got all that? We got it all? Alright, well, I'll see you in the next problem. I'm going to take a break. I think I'm going to go outside, enjoy the sun for a minute. Okay, we'll see you later. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to complex fractions, and we're looking at 6.1. Whoa, what is all that? Simplify the complex fraction. So we got 19 over x plus 20 over x, and that's all over 5 over y plus 11 over y. Okay, got it. We got it. So 19 over x plus 20 over x, and that's all over 5 over y plus 11 over y. So we'll go ahead and add both those fractions together. So that's going to be what, 39 over x, and this will be 16 over y. Right? We have a common denominator, so we just rewrite it as you can see here, and just add the numerators. Now, this can be written as 39 over x, and we're skipping this particular step now where we'd put divided by. We just go ahead and flip this fraction, y over 16, right? We normally write 16 over y, but with the division symbol here, but we're skipping that particular step. And now we have 39 y over 16x, and of course the question is, will 39 and 16, what do they got in common? Will that reduce down any? And No. So there you go. All right. 39y over 16x, I think it was. Wait a minute. What is going on here? Okay, let me see something here real quick. Okay, that's all right. It's all correct. Has to be. So we got 39y over 16x. Just making sure. Making sure. Okay, so we are over here at gotomath.com. See you in the next problem. Okay, we're at gotomath.com. Click on Algebra. Let's go down to complex fractions. And we're looking at 6.2. 6.2. So we have x over 2 plus x over 5. And that's all over y over 11 plus y over 17. All right. So we have x over 2 plus x over 5. That's what it says. And I was thinking wrote that down wrong or something. Y over 11 plus y over 17. Okay, so let's go ahead and work on the numerator. Work on the numerator first. Okay, so we're going to multiply. We're going to have 5x, we're skipping steps now, plus 2x, and that's all over 10. 5, 6, 7, x over 10. See that? So remember, if you forgot, we'd write a 5 over 5 here, and then a 2 over 2 here. You see that? And 2 times 5 is 10. Right, then we'd have 10, 5x, 2x, and so forth. Okay. Now let's look at the denominator here. We're going to have, let's go back to blue. We're going to have 17y plus 11y, and that's all over 11 times 17, which is what do we got here? So 17 plus 11 is 28. Y, that doesn't look like a Y, does it? That's right, that so looks a little bit more like a Y. And then 11 times 17, and we get 187. 187, there you go. Alright, so let's rewrite this over here. We have 7x over 10, and that's all over 28 y over 187. So we have 7x over 10. Now we're going to write multiplication, flip this fraction, 187 over 28y. Now, let's see, what can we do here? Can we do some canceling out? Let's see, 28, 7 goes into 28 4 times, so I know we can, let's use a different color here. How about this color? We don't ever use that color. So that's like a 1, and then this would be a 4, right? And then what about 187? Either 2 or 5 goes into it, and 2 doesn't go into it, and neither does 5, obviously, so those aren't going to do any good. Not going to do any good with that. Alright, so it looks like 187 will stay in the numerator along with this x over 10. And wait a minute, we got this 4 right here, so we'll need to yeah, we'll need to do something with that. So let's erase this here. So we're going to end up with 10 times 4, which is 40. And that looks like y right there, right? And that shouldn't reduce down any at all. So there you go, 187x over 40y. 187x. That was quite a bit going on there, wasn't it? Yeah, over 40y. There we go. Okay. Alright, that's not where I wanted to go. Let's go back to the home page. There we are. Alright, I'll see you in the next problem. Okay, we're at gotomath.com. Click on the algebra. Let's go down to complex fractions. And we are 7.1, it looks like. Things are getting crazy now. Things are getting crazy down there. 12 minus 1 over x and 16 plus 1 over y. Alright. What do we got going on here? I guess we're going to rewrite that. 12 minus 1 over x and 16 plus 1 over y. Okay, so let's take a look at the numerator, and we're going to be just how about I do this. Okay, so we'll need to write an x down here so we have common denominator, but if we do this down here we must write it up in the numerator also. Does that make sense? You know what, let's go ahead and take care of the denominator also while we're at it. So we need a y down here, but we have to write a y up in the numerator. Not too bad. We'll continue this right over here. We'll write equals there. Okay, so this is going to end up being 12x minus 1 minus 1 over x, and then we have 16y plus 1 over y. You like that? Alright, so now we're going to write 12x minus 1 over x, and instead of writing a division symbol here, we're going to put multiplication there, and we're going to flip this fraction, so we're going to have y over 16y plus 1. How do you like that? You may not like it at all. So what can we do here? Well, basically all we can really do is just distribute this y across. So we're going to write 12xy minus y over, since nothing cancels out, and then we're going to have 16xy plus x. I think that's where we'll end that problem. Okay. 12xy minus y, whoops, 16xy plus x, yeah. Okay, 12xy minus y, 16xy plus x. Alright. Looks good. We're over here at gotomath.com getting it worked out. See you in the next problem. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to complex fractions and click on, let's bring 7.2 up. And comparing that with the last problem, it's kind of like it. So we have 1 over y plus 16 over 1 over x, and then minus 19. Okay. Alright. 1 over y plus 16, and then that's all over 1 over x minus 19. So let's look at this numerator up here. We got 1 over y plus 16. So we're going to need to get a common denominator, and that means I'm going to write a y down here, but then I got to write a y up in the numerator. Okay. That's pretty easy. Takes care of that, doesn't it? We have 1 over x minus 19. And so we'll need to do the same thing here. We're going to write an x down here, so now we have a common denominator, but we got to write an x up in the numerator. All right. We'll continue this right over here. So we're going to have 1 plus 16y. You could write this 16y plus 1, it doesn't matter, over y, and that's all over 1 minus 19x over x. And of course we're going to want to simplify that down. That's a 16y there over y. Now instead of writing division, we're going to write multiplication. That means we're going to flip this fraction. So we're going to have x over 1 minus 19x. See that? And let's go ahead and distribute this x across. So we're going to have x plus 16xy, and that's going to be over y minus, run into this crazy thing, 19xy. Okay? Kind of sloppy, but hopefully you got it. Alright. Hopefully. Everything's working out there. And let me look at that again. X plus 16xy and y minus 19. Okay. xy. Just making sure before I bring that up, you know. Okay. So we are done with that problem. And we're over here, GoToMath.com, so come on by, check it out. See you later. Okay, let's go up to Algebra. Go down to complex fractions, and we're looking at 8.1. Looks like that's it right there. Alright, so let me write that down. And you should be writing it down also. Okay. So we have 8 over x plus 13 over y, and that's all over 9 over x minus 3 over y. Okay. So let's work on this fraction up here in the numerator, adding these two together. Okay. Excuse me. So this ends up becoming, right, we would write y over here and then x over x to get a common denominator. But we're going to skip that step because I feel if you've been following along in these sections that you should be able to follow that. Okay, so we do the same thing over here. So 9y minus 3x, right? And that's all over x times y. That didn't quite look like a 9 there, does it? Okay, so now what we're going to do, instead of bringing this out and writing the division symbol, we're going to go ahead and just write multiplication. So we have 8y plus 13x over xy times, right, so we're going to flip this, so we have xy over 9y minus 3x. And then what we can do here is we can cancel those out. And looks like that's all we can cancel out with that. So we're going to be left with 8y plus 13x over 9y minus 3x. So something we need to look at, is there a number we could actually factor out of both these terms up here in the numerator, and it doesn't look like there is, because we'd want to pull that out and then pull whatever we can pull out here and then cancel terms out if all possible, right? But it doesn't look like that's the case. Doesn't look like it. So we had 8y plus 13x and then 9y minus 3x. Just making sure that's all good, looks good. Okay, so we're over here at GoToMath.com. See you in the next problem. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to complex fractions, and we're looking at 8.2. 8.2. Okay, so we have 8 over x, 18 over y, 8 over z, minus 9 over y. Okay, got it. No, we don't want to do that color. Stick with blue there. Okay, so we start off with 8 over x just like we did in the last problem. What's the probability of that? And then we have 18 over y, and then that's all over something. It's over 8 over z and minus 9 over y. Alright. So let's go ahead and get this all into one single fraction here. So this is going to be 8y plus 18x over xy. Okay. And then this one here will be 8y minus 9z over zy. Let's get up there, we can still see that. So we'll go ahead and rewrite the 8y plus 18x over xy times, so we're going to flip this fraction, zy over 8y minus 9z. 9z. So the only thing I can see of that's going to cancel out are these y's right here, since this is multiplication. And there's no numbers we can factor. Oh, wait a minute. But I don't think it's going to matter. So, yeah. We could factor, let's see, what is that? 9 and 3, 9 and 2. We could factor a 2 out, but that's not going to help out any. We're going to go ahead and distribute this z across. So we got 8y z plus 18x z. And then this will be 8xy. We're distributing this x across. Minus 9xz. Alright. So let's take a look at what the program script says. Hopefully everything agrees. 8yz plus 18xz, 8xy, 8xy minus 9xz. Yeah. Okay. So we're over here at GoToMath.com. See you in the next problem. Okay, we're at GoToMath.com. Click on the algebra. Let's go down to complex fractions. And we're looking at 9.1. Complicated fractions. That's what some might call them. 1 over x plus 14. So we're going to write this down here. 1 over x plus 20. That's all over 2 over x and x plus 14 plus 34 over x plus 14. Okay. I'd like to just be writing all this down on a notebook and videotaping that. And man, I tell you what, I could really go, and then with a fast internet connection, I could probably cover an entire course in a couple days. But we got to go through this process. I don't know, I may experiment with that with some other course. There has been people out there doing that. This is extremely time consuming what I'm doing, because I've got a web page that corresponds with each one of these problems, and you got to program it. You got to check the problem a couple different ways. You know, there's a lot going on here. Okay, do I have enough room over here maybe? Eeks, we'll try it out. So once again, we're going to multiply this side over here by x plus 20 over x plus 20, and then this side will be x plus 14 over x plus 14. But instead of doing that, we're just going to take this and multiply it by the 1, and here we won't even skip that step. We'll just say 1 times x plus 20 plus 1 times x plus 14, and that's going to be all over x plus 14 times x plus 20. Okay, so that'll be the numerator, and then we'll go through and do the same thing with the denominator here. Now you noticed in the denominator we have a common denominator, so that makes things nice. So this just becomes 2x plus 34 over x plus 14. And we'll go ahead and simplify the numerator up here. I can get it all on the same page. So we're going to have x plus 20 plus x plus 14. We want to combine all that like terms, so that's going to be 2x plus, and then we got 20 plus 14, that's 34. And of course, that's going to be all over. And we're not going to multiply this together just yet. Okay, let's not do that just yet. So we have x plus 14 times x plus 20 times, okay, so we're going to flip this fraction here. We're going to have x plus 14 over 2x plus 34. Now I see some stuff that can cancel out. We got a 2x plus 34 up here, 1 down here. We've got an x plus 14, an x plus 14. So that's going to clean up pretty good. So we're going to end up with not much. 1 over x plus 20, it looks like. 1 over x plus 20. How do you like that? That thing cleaned up. There we go. Alright. So we're over here, go to math.com. See you in the next problem. Okay, we're at go-to-math.com. Click on the algebra. Let's go down to complex fractions, and we're looking at 9.2. 9.2. So we have 15 over x plus 7 plus 17 over x plus 18, and that's all over 32x over x plus 7 plus 389 over x plus 7. Okay. Alright, so we have 15 over x plus 7, and that's going to be plus 17 over x plus 18. That's all over, looks like a crooked line, 32x over x plus 7 over x plus 7. Okay, so the first thing we'll do is go ahead and get this to one single fraction. So we're going to end up having 15 times x plus 18 plus 17 times x plus 7. And that's going to be all over x plus 7 times x plus 18. Alright. And now we have a common denominator here, so we just need to do 32x plus 389, and that's going to be over x plus 7. Okay. So what we'll want to do here is clean this up. So I'm going to actually skip some steps here, and hopefully you can keep up. So we're going to have 15x and a 17x, and 15 plus 17 is 32x. Okay. And then of course we distribute the 15 to the 18, and then the 17 to the 7, and then add both of those guys together. So we got 15 times 18 plus 17 times 7, and 389. I'm lost the cursor. Where'd it go? There it is. Plus 389. And then let's not multiply that stuff together just yet. Oh my God. Okay. Great. So we end up with x plus 7 times x plus 18. And now what are we doing? We're doing multiplication here times x plus 7 over 32x plus 389. So we can cancel that stuff out, and looks like we can cancel that out. Canceling everything out, aren't we? And so we're left with 1 over x plus 18. 1 over x plus 18. Okay. Where are we at? Answer 1 over x plus 18. There we go. Okay, so we're over here at gotomath.com. Wondering what's about to take place next. Just got a phone call. I hope it's positive and not negative. Actually, that doesn't sound good. I hope it's anyway, never mind. Okay, what am I doing? Let's end this video right now. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to complex fractions, and we're looking at 10.1. Alright, over here talking to myself. Forgot I was on the microphone. 1 over x minus 5. 1 over x squared. For some reason they didn't leave a message. Just got a phone call a second ago. Well, they didn't leave a message. Maybe they just accidentally dialed my number or something. Okay, what are we doing? Let's sidetrack there. This is some fishy stuff going on over here. We might want to take a closer look at this, and that is we might want to try factoring that. I got a feeling. Let's see. Will that even factor? It doesn't look like it. 5 and 5 is 25, but how do you get a 5 there? Well, it doesn't look like it, so okay, maybe I'll try doing this. Alright, so we'll just have to multiply whatever's down here times 1. So that's going to be x squared plus 5x plus 25, and then plus, and multiply this x minus 5 times 1, and then that's going to be all over x minus 5 times x squared, let's see, plus 5x plus 25. Okay, and then of course there's not really much we can do down here. Now I do see that this is a difference of 2 squares, and I may actually just write it like that. So this is x cubed minus 5 cubed. See that? Okay, well, let's go ahead and clean up the numerator up here. We got x squared. We're going to have a 5x plus x, that's 6x, and then 20. So we'll go ahead and write that. So we have x squared plus 6x and plus 20. Okay. And then that's all over x minus 5 times x squared plus 5x plus 25 times, and then we'll flip this fraction. Now I will say something here. We can factor this, okay, to x minus 5 times x squared plus 5x plus 25, and that would be all over 1 if we wanted to look at it that way. Now it looks like we can do some canceling here, right? I don't know if that was intentional or what. Imagine that. And so it looks to me like we're going to be left with an x squared plus 6x plus 20 over 1. But it looks like that's it right there. Wow. Don't act surprised. X squared plus 6x plus 20. Yeah, that's it. Okay, so we're over here, gotomath.com, getting it worked out, and I'll see you in the next problem. We're over here at gotomath.com. Click on the algebra. Let's go down to complex fractions, and let's hit 10.2 there. Alright, we got 17 over x minus 4 minus 17 over x squared plus 4x plus 16. And that's all over 17 over x cubed minus 64. Okay. Alright, so we got 17 over x minus 4, and that's minus 17 over x squared plus 4x plus 16 and we got x cubed minus 64. Okay. So let's take a look at this here. Doesn't look like this can factor down here. 2 and 8, 16 and 1. There's no way we can get 4. 4 and 4, no. Okay, so we're going to do the cross multiply thing. So this is going to become 17 times x squared plus 4x plus 16, and then minus 17 times x minus 4, and that's going to be all over something, x minus 4 times x squared plus 4x plus 16. And what a mess that is. And you know what? We're gonna go ahead and just write times over out here and then flip this fraction. Now this guy right here is a difference of 2 cubes, and that 64 would be 4 cubed right there. Okay, so this is going to end up being x minus 4 times x squared plus 4x plus 16, and that's going to be all over 17. Okay, now let's go ahead and distribute this stuff and clean this up here at the top. Alright, clean that up. And actually, those guys actually just cancel out, don't they? Why don't we just do that right now? We can cancel those out and cancel them out. And you know what? We're left with 17. And you know something? I think... See, we got a 17 and a 17 and then a 17 down here. That means that we can cancel these 17s out. See, because this would just be written as 17 over 17, then 17 over 17. You see that? Or you could think of it as multiplying 1 over 17 all the way through. Yeah, that's what we're going to do. Alright. So then we're going to be left with an x squared. We've got a 4x. Now we got this minus sign right here, and we'll need to distribute that across. So that's going to be minus x. So we're going to have 4x minus x, and that gives me 3x. And then we have 16, and of course we'll need to subtract it. That'll make that a positive 4 if we distribute the negative across, so it makes that a positive 4, so that's going to be a 20 there. Right, be 16 plus 4 is 20. Wow, that's what we needed to do. So it would have been kind of a mistake to multiply the 17 all the way across, right? because then we just have to, and then, yeah, it'd be a big waste of time. Alright, so we have x squared plus 3x plus 20. Imagine that, all that reduced down to the nothing. Practically, isn't that amazing? X squared plus 3x plus 20. Yeah. Alright, so that is 10.2, and that is going to end this section, and I'll see you in the next section.